Hello 8th graders. In this IXL video we're going to be taking a look at assignment I.5, which is called Write Equations for Proportional Relationships from Graphs. So as the title suggests, you're going to get graphs of a proportional relationship, like we see here, and your job is to write the equation that would match that graph. So for all these problems it will be important to read through the word problem. We'll do that in a second. But first I just want to cover the basics of equations for proportional relationships. It turns out equations for proportional graphs are pretty simple, since it has a constant rate of change that just starts at 0, 0, the origin. All we need to know is that constant rate of change and to multiply that with x. And once we take that ratio, that constant proportion, and multiply it with x, it always tells us y. So the equations are simple as soon as we know whatever k is. K is our fancy letter for the constant of proportionality. So if you ever see y equals kx, we're just saying every proportional equation takes this form, and whatever the constant ratio of y over x is the coefficient, the number you plug in to multiply with x. So in this case, I'm going to look at the graph. I need to find a data point. I'm going to pick this data point right here. We're going to use the color purple. And right here, you see me kind of marking up a data point. And I see if I draw a few arrows, I see that the x value is 2. And I see with another arrow that the y value is 6. Oh, that's backwards. Again, it lines up with 2 ounces of dark chocolate for every 6 ounces of almonds. So I'm going to call that 2 chocolate, 6 almonds. And so our constant ratio, remember, this is the key. The ratio has to be y over x. So when I set up this ratio here, the top of my ratio is going to be the 6 almonds, or the numerator is going to be the 6 almonds. So let me go ahead, put a 6 here. That represents 6 almonds divided by the 2 ounces of dark chocolate. And that's going to give me 6 divided by 2 is a ratio of 3 over 1. And we can kind of see that here. This graph climbs by 3 ounces of almonds every time we go right by 1 ounce of dark chocolate. So that's our constant ratio right here, 3 over 1. And I can simplify that even further. If my ratio can be put into a whole number, we want to do that whenever we write equations. We like the equation to be as simple as possible. So our rate of change, our constant ratio, is 3 over 1, which simplifies to 3. And that means our equation is just going to take the form y equals 3 times x. Every 1x, every 1 ounce of dark chocolate gets us 3 more ounces of almonds. That's all this equation is saying. We're going to show you one more example. 1 second to clean the screen up a bit. Great. So for this next example, we're told Jackie's a small child, favorite food is carrots. And there's a proportional relationship between the size of Jackie's garden, the square feet, how big her garden is, and the number of carrots she can grow. And as she grows older, of course, it looks like she starts growing, she makes a bigger garden, she can get more carrots. But our big thing here, we need to find this constant ratio of y divided by x. So I'm going to follow this line that represents Jackie's garden, and the first data point that I see, right here where my mouse is, we're going to go ahead and put a purple dot right there. And we see that the data points here, this has 1 for x and 9 for y. It lines up with 1 on the x-axis, 9 on the y-axis. And so we'd call it at 1 square foot, she can grow 9 carrots in this garden. And we see because it's a straight line starting at the origin, this ratio is going to hold constant forever. And so our proportional, or our constant ratio that gives us this proportional relationship is y over x, or for this data point, 9 carrots, divided by 1 square feet. And 9 divided by 1 just gives us a ratio of 9, so that tells me this equation is y equals 9x. What does that mean? Y equals 9x in this problem means every square feet, or every square foot, every x in this garden allows us to have 9 carrots that are grown. And we'll see that keeps growing. The more square feet you have in the garden, the more carrots you can grow, and it's 9 carrots per square foot. That's why we see that straight line. We're going to skip ahead a couple questions to something a bit more difficult. We think at this point you definitely got the things you need to start working on this on your own. So as you get later on in this IXL assignment, they're going to start preparing you in 8th grade because not every graph we get is going to be proportional. If you recall from Mr. Neville and what we've talked about, proportional graphs, the only way y over x hold the same ratio the whole time is if they start together at 0 and 0 for y and x, if we start at the origin. Here, we have an initial value when x is 0, y is 2. So if I did 2 divided by 0, you can't even really divide by 0. Or if you do, it goes into a million parts. So basically 2 divided by 0 can't be done. I know right away all these other ones, 4 divided by 2 is going to give me a different ratio than 2 over 0 because I can't even really divide by 0 by the rules of math. So if I don't start at the origin, I can't be proportional. And we're going to dive into that more in future weeks about how to handle these graphs that are not proportional. How to see if they have any kind of constant pattern or rate of change. But for now, all we need to do is recognize if it doesn't start at the origin, it's not a proportional graph. And other times it looks like as you go, they will give you a proportional graph. So I could say, yes, this starts at the origin, it's a straight line, it's proportional. And then once you see it's proportional, they make you write the equation. Here, if we pick this out, the thing that might be more challenging about this problem, it's a little harder to find a good data point. So if I'm following or tracking this line, I want to find a data point that's clearly on the corner of a grid box. And the first grid box I see this pierce to the corner of, we're going to use the purple color again, is right up here. And at this point, it's lined up with 5 days and 20 lines. So here this x-axis is jumping by more than 1. Every line counts for 5 days or 5 units on the x-axis. So our coordinates here, we have 5 days. I'm going to go ahead and label it right away. 5 days, and during that time we get 20 lines. And this is about memorizing lines in a play. So we have a girl, and this tells us she doesn't know any lines to start. She starts learning them at a constant rate, and by day 5 days in, she's learned 20 lines. So we could go ahead and now write a ratio for that. Y is the 20 lines divided by the 5 days. And 20 divided by 5 is the same as 4 over 1. We could simplify that ratio. Or we could even simplify further to say, hey, this is a ratio of 4 to 1, or just simply 4, meaning she gets 4 lines every day. So she's learned ultimately 20 lines from her play by day 5. That's because she got 4 every single day, 4 or 5 straight days. Tells us our equation is just going to be y equals 4 times x. Every day she learns 4 new lines from this play, so 4 times x will tell us the total number of lines from the play she has memorized. We'll submit that answer, see if it's correct. We're going to jump into the one that's the challenge zone in the 90s to see if there's anything really crazy there. Here we go, now entering the challenge zone. And again, we don't think you should still be watching the video, but if you're really stuck on the challenge zone ones and you're looking for some help, here's where it's going to be. All right, cool. So we have a graph that is a proportional relationship. That's the first thing the challenge zone will make sure you can tell if it's proportional or not. For the ones that are, go ahead and say yes. They're going to make you come up with an equation. And here we see the challenge is there aren't many good points on this blue line. If I track where it is, and I'm looking for nice, easy corners of grid boxes that I can clearly tell the coordinates. I come close here, but if I zoom in, I can see it doesn't actually hit this little corner here. So I'm going to keep going. They're trying to trick me into using that point, but it's not actually accurate. I shouldn't be using it. I'm going to keep going, and finally, we'll zoom out a little more. Finally, I can see right here this data point, which we're going to go ahead and put in purple one last time. This is the first good data point on this graph that we can really use. And now I can see, okay, it lines up with 25 laps. Okay, we must have somebody who's in a hospital, they're doing laps. And then, ooh, how many dollars they earn. Okay. So we're earning $800 here for 25 laps. So 25 laps is the x, $800 is our y. And when we calculate this ratio, this is the tricky piece. I need to do y over x first, so I'm going to be doing for my ratio 800 divided by 25. Now you could use a calculator, but I know 25 is a quarter, and I need 4 quarters to get to 100, and I know that 4 times 8 is 32. So if 25 times 4 is 100, and I need 8 of those, 8 times 4 gives me 32. I did some mental math there. I'm going to go ahead and check up here on my Google calculator, confirm that 800 divided by 25 is indeed 32 over 1, like my brain thought. And now I know this is the constant ratio. Every one lap is leading to $32 that are raised for this track team, I guess. So my equation, using that constant ratio, if X represents laps, I multiply that by the $32 per lap, and that will tell me Y, the total amount of dollars that are raised. Hope this was helpful if you were watching to the end. Thanks for checking out the Challenge Zone.